Welcome to my channel, The Sake of Physics. In this video, I'm going to show that how can we find a resultant vector of two vectors if the rectangular components are given. So in the figure, you can see that OS line shows vector A, while OQ line shows a vector B. Using the head to tail rule, we can add them and find the resultant vector, which is A plus B. So if I write down so you can see in the figure that OL equals OM plus ML, which is the x component of vector A and x component of vector B. So I can write down AX plus BX, where OL shows uh, the resultant vector magnitude. So here I'm writing down in their magnitude form, not in the vector form. Similarly, LP equals LN plus NP, where LP is RY and LN is AY and NP is BY. So these two are the y components of vector A and B. So if I write down in the vector form, then Rx vector will be equal to AX vector plus BX vector. Similarly, Ry vector will be AY vector plus BY vector. Or I can write down R equal Rxi plus Ryj. So we know that in for the magnitude of a resultant vector, we can use the Pythagoras theorem, and this will become Rx square plus Ry square. So if I plug the values in, then R will become AX plus BX square, and Y component is AY plus BY whole square. Similarly, for the direction of the resultant vector, tangent theta will become Ry over Rx, or I can write down, because Ry is AY plus BY and Rx is AX plus BX. So here I can find the direction of the resultant vector, either Ry or Rx, or tangent inverse AY plus BY over AX plus BX. So if there are more than two vectors, instead of A and B, if there are more vectors A, B, C, and D, then the resultant vector will become AX plus BX plus CX plus DX plus so on. I mean, if more than four vectors are given, plus AY plus BY plus CY plus DY whole square. And similarly, the angle will be the same way. We can write down AY plus BY components on the top and X component will be the bottom by the definition. So this is the general form for the direction and magnitude of resultant vector if there are more than two vectors are given. So if here I can generalize for the direction, if rx and ry, if they are both positive, when you find them out and you get the positive answer, then it means that the resultant vector lies in the first quadrant and the final angle theta equals phi. For example, if uh, this is the case, and this is phi, then theta equals phi. But what if Rx is negative but Ry is positive? This is the case when resultant vector lies in the second quadrant. Here Rx is negative and Ry is positive. And this is some angle phi. Then theta will be 180 minus phi. But if Rx and Ry both negative, then it means that the resultant vector lies in the third quadrant. This is some angle it is making with the negative x-axis, then total angle theta will be 180 plus phi. So I'm talking about this angle theta. This is angle theta. What if Rx is positive and Ry is negative? Then it means the resultant lies in the fourth quadrant and this will be angle phi, then theta will be 360 degrees minus phi. So this will be angle theta. So these are the general rules to find the direction of resultant vector with respect to positive x-axis. Thank you so much for watching.